The three most important factors when specifying a transformer are the size of the transformer, the kVA rating, the winding configuration, and the voltages. For size, keep in mind the transformers can be overloaded slightly. So talk to your manufacturer about what's reasonable overloading that would still maintain your transformer life based on your expected plant performance and your inverter loading. So for example, if you have a 1 megawatt inverter, you probably just use 1000 kVA transformer. Easy. But what if you have 1100 kilowatts of string inverters? Then you can ask, well, should you go up to a 1250 kVA transformer, or do you stick with that 1000 kVA transformer? Well, you still might be able to use that 1000 kVA transformer because you're only going to be loading it up fully for a few hours a day. That answer might be different if you're in Massachusetts versus Arizona, or for different types of transformers. There's some transformers that are designed to be able to operate continuously at 110% load, just like your engineering team. The low and high side voltages of your transformer should be given based on the inverter output and the good voltage. But just keep in mind your voltage tap range and any voltage drop that you might expect. The winding configuration and grounding scheme can be a bit more complicated, and you'll really need to get into detail with both the inverter manufacturer and the utility on the requirements. And that's, is it two winding or three winding? Is it delta Y delta, and where the grounding is? All of the specs that I just mentioned are definitely going to be variable on every project, as well as things like number of terminal bushings, if you've got loop feed. But then there's a whole slew of other options that you might be able to largely standardize on for all your projects. That includes things like insulation levels, temperature rise, bushing rating and quantity, what type of spades you're using, whether you want to include surge protection or not. As I mentioned before, this is just the tip of the iceberg in terms of the options you'll need to consider. If you're unsure if you're getting good and unbiased, knowledgeable advice from your distributor, then get an electrical PE involved to help you decide what options are necessary or will add value to your project. One other important consideration with transformers is the efficiency. You probably have the option to meet the latest Department of Energy standard efficiency at an added cost. And you can run models using PVsyst or Helios Scope to help you decide if it's worth the extra cost for the higher efficiency. But I'll just say that it probably is. Take that for what it's worth. One last thing to keep in mind is oil spill containment. This is not a transformer spec per se, but something you might need to plan for outside of the transformer. The EPA, they have a requirement for oil containment, and there's lots of ways that you can accomplish oil containment, by the way. But the oil containment is required if you have more than 1,320 gallons that has any chance of spilling into a U.S. waterway. A U.S. waterway is basically any creek or body of water that you can put a kayak in. Now, your company may want to be more prudent than meeting the minimum requirements of the EPA, and include oil containment measures for smaller quantities of oil or in other environmental scenarios. The benefits of that are that it reduces liability and cleanup costs in the case of a spill, but you have to pay for the upfront cost of the oil containment. And I would also mention that your transformer will almost certainly use an oil called EnviroTemp, which is a biodegradable vegetable oil, but still pollutes and it is still regulated by the EPA.